Hello and welcome to Wesley and Casey final project, noise meter. So we have current coming in here, going to our voltage regulator, which then passes the current on through a couple capacitors in order to keep the current at a specific level. Passes the current here, splits part of the DC current into our microphone system and part of the DC current into our light board system. The energy going into our microphone system first goes straight to the mic, which then gets AC current, which is then the DC current is stripped off of it using these capacitors, passed into our operational amplifier, which amplifies the AC current, and then passes again through another capacitor to take away any DC current added, and gets stripped once again, and then gets transferred by these diodes into DC current, so that we may pass it to our monolithic IC.
So once the signal from our microphone comes into our 18-bar integrated circuit, monolithic IC, as Wesley mentioned previously, that voltage is actually going to be compared to the voltage coming in from our reference voltage. Our reference voltage is a system coming from, again, the integrated circuit as before. So what it does is inside this circuit there's a bunch of condensers for each LED as it's shown before. So whatever voltage that this signal from our microphone is at, it's going to be compared to the reference voltage at each of these levels. Now, if the signal is higher than the reference voltage, then we're going to get an LED to show on. So as we go on, this program is actually set so that each one of these LEDs will light up at 3 decibels of sound. So it goes 3, 6, 9, and so on, letting you know about the sound level that you're experiencing. Once it is set up it is actually set up for 30 volt maximum, which is known as one of the last points of safe sound levels. So once it hits 30 decibels or lights up this last LED, this buzzer is going to go off, letting you know that it is unsafe for you without ear protection.
Okay.